And I will say my plan is to get through these examples. If there's, a couple that we don't get to at the end, we're still continuing this tomorrow. But 8.2 is on adding and subtracting rational expressions. When you add and subtract fractions, so for example, I'm just going to write this on the top. Say I want to add 1/2 plus 1/3. What do I have to do in order to add those?
Find a common denominator.
Common denominator. So the same applies if, and I know this isn't until we get to the back, if you take a look at the back though, example 2, in order to add these two rational expressions, their denominators have to be exactly the same. So it's that same idea of finding a common denominator. So the first part of this, so ladies in the back, I need your attention up here, please. The first part of this is being able to find the least common multiple of polynomials. Because when you find a least common denominator, what you are finding is the least common multiple of whatever the denominators are. This explains up here how to do it. I'll be going through how to find them as well. And then there's a couple of examples. I guess I'm just going to jump right into example 1, part A. So we're finding the least common multiple, the LCM of each set of polynomials. And A, we have 12a squared b, 15abc, and then 8b cubed c to the 4th. So if you picture these three terms all as different denominators, you're trying to find what would be the common denominator then. What's the least common multiple? So when you have expressions like this where each is just one term, I typically first look at the coefficients of those terms. So we have 12, 15, and 8. And I would start out by finding first the least common multiple of 12, 15, and 8. So a number, not a least common factor or a greatest common factor, but a least common multiple. What's the smallest number they all go into? And there's different ways to do this. I know you've done this before because you've worked with fractions before. I typically will look at the largest one. In this case, it would be the 15. And I start listing multiples of 15 until I find one that the other two numbers both go into. So for example, if I start with 15, 15 times 1 is 15, but I know 12 and 8 do not go into 15. So then if I do 15 times 2, that's 30. Do 12 and 8 go into 30? No. If I do 15 times 3, 45. 12 and 8 don't go into 45. Next multiple of 15 would be 60. 12 goes into 60. 8 does not go into 60, so I have to keep going. 75. 12 and 8 do not go into 75. 90 would be the next one. 12 and 8 don't go into 90. 105 would be the next one. 12 and 8 don't go into 105. 120. 12 does go into 120. 12 times 10. Does 8 go into 120?
I hope so.
Yes. So are they all like this? No. So 120 would be the least common multiple for 12, 15, and 8. So I know my least common multiple, the coefficient will be 120. The variables are easier to work with. What you want to do for each variable that you see, the least common multiple is going to be that variable with the highest power that you see. So I have three variables. I have a, b, and c. My first term has an a squared. My second term has an a to the first. My third term doesn't have an a. So the least common multiple for the a's would be the highest power of a, which is a squared. Okay, so if one of them has an a squared and you were trying to get all of them to be the same, they would all have to become a squared. You'd multiply the other one so that you had an a squared. That's the idea. So then for the b's, I have a b to the first in the first term, and in the second term, the third term has a b cubed. So my least common multiple will have a b cubed, the highest power of b. So I would have to get them all to have a b cubed. And then for the C's, first term doesn't have a C, second term has a C to the first, last term has a C to the fourth, so the C to the fourth is the least common multiple. I would have to get them all to have a C to the fourth. Okay, so this is your LCM, least common multiple, for those three terms. So again, if these were all denominators, you would have to then multiply each of those fractions by something so that every denominator was 120 a squared b cubed c to the fourth. That's kind of what we're working towards. This is just how to find the least common denominator, which is the least common multiple. So I'd like you to then do example B. Find the least common multiple of 6xy, 15x squared, and 9xy to the fourth. So try it. I'll make a quick walk around. If you're totally stuck, let me know. Otherwise, I just want to give you a chance to try it, and then we'll check.
It goes into 90 divided by 9. And then 6 was 15. And the tie. So you can tie.
It's like that. Yeah, rainbows. I don't know why they did it.
All right.
I don't think they are. I got 9 points for that.
I haven't even done any freaking trailers and outfits coming out this year. It's still really not. Oh yeah, but it's kind of hard to I don't know that.
All right. Just because it seems like everyone has an answer, just double check. You should have 90 x squared y to the fourth. So again, you will see these questions as separate, but always be thinking you're trying to make them all equal the same thing, not find a common factor. It is different than what we've been working with. So then for part C, I need your attention back up here, please. Part C, C and D are different. Guys, can we just put the phones away, please? Okay, so you all need to realize when you should and shouldn't be on your phones. But while I'm trying to teach, I shouldn't see people showing each other pictures on phones. That they're a huge distraction. Just put them away. Okay, I like to be on my phone too. You don't see me touch my phone at all during the class period. You don't need it right now. Just put them away. C and D are different from A and B. A and B, all that were listed were monomials. C and D, you have polynomials. So just notice where the comma is, where the separation between them is. So if we look at C, in order to find the least common multiple or least common denominator for these, you want to make sure each polynomial you have is factored. So factor them first. So if we look at the 4a squared minus 12a minus 16, if I wanted to factor this, first of all, I see that there's a greatest common factor of 4 that I can factor out. So I would have 4 times the quantity a squared minus 3a minus 4. And then I still have the a squared minus 3a minus 4, which is a trinomial. So I should set up a diamond to see if I can still factor that. So setting up a diamond, we'd be multiplying then to negative 4 and adding to negative 3. What two numbers work there? Okay, so I'd still have the 4 in front, and then I would have a minus 4 times a plus 1. So that's the factored form for that first polynomial. Now I also want to factor the second one. So here I have a cubed minus 9a squared plus 20a. First of all, always look for a GCF first. This trinomial has a GCF of a. I can factor out an a first. I'm going to draw this line to keep these separated. So I have a times, and if I factor out the a, then I have a squared minus 9a plus 20. And then the a squared minus 9a plus 20 is still a trinomial. So if I try to factor that, I'd be multiplying to 20 and adding to negative 9. What two numbers work there?
5 and negative 5.
Yep, negative 5 and negative 4. So I'd have a times a minus 5 times a minus 4. Okay, so then once they're both factored, again, you're picturing these as if these are denominators in a fraction and you want to make them the same. That's what the least common multiple would be, is what would it take to make them the same. So the least common multiple would be, first of all, I'm going to highlight one thing. Note anything that they share, any common factors they share. So the only thing they have in common would be the a minus 4. So that's definitely going to be part of the least common multiple, but that's the only thing they have in common. So you want to make sure every factor you see is included. So if I wanted to make these the same, this one has an a and an a minus 5. I would need to make sure this one also had an a and an a minus 5 in that case. This one has a 4 and an a plus 1. I would need to make sure this also had a 4 and an a plus 1. So the least common multiple is going to include the 4 and the a. I'm just writing the GCFs in front. It's going to include the a minus 4, but because it's shared, I only do need to write it the one time. And then it's going to include the a plus 1 and the a minus 5. So it includes every factor you see, but if a factor is shared, you only would need to include it the one time. As we move forward and put this together to actually get common denominators to add or subtract fractions, hopefully that'll make more sense. I just want you to know how to just find the least common multiple aside from when you're just adding or subtracting. So are there questions on C? Okay, go ahead and find then the least common multiple for D. Try it out. Again, I'll take a walk around. Let me know if you have questions, and then we'll just check, make sure we have it before we move on. and let me know if you have it factored. You're just having trouble coming up with LCM, let me know. So we're here. Okay. All right, double check. I know you weren't all quite finished when I walked around. So the first polynomial, you can factor out a GCF of y squared. And then you still have a trinomial to factor. The second one is a trinomial to factor, so this should be your least common multiple. Y squared, y plus 5, y plus 3, y minus 8. Okay, questions on D right now. Now we'll get to actually using the common denominators to add and subtract fractions. So, like we talked about, when you see problems like what is on the back side of this sheet, you're adding or subtracting rational expressions. You cannot add or subtract if the denominators are different. It's the same as if they were just numbers. So if we look at example 2, we need to make 6b and then 14a squared b squared. We need them to have the same denominator. So this is where you'd want to find the least common multiple, which is the least common denominator. So first of all, I have a 6 and a 14 for coefficients. I know 6 doesn't go into 14, so I want to find the least common multiple. If I list multiples of 14, I have 14, and then 14 times 2 is 28. But 6 doesn't go into 28. 14 times 3 is 42. 6 goes into 42, so 42 is going to be part of my least common denominator. And then what will I have for variables in my least common denominator? A squared and b squared. Okay, so you need to have every variable you see between the two, the highest power that you see. So I need to make them, what's happening is I need to make both of these fractions, I need to multiply them by something so that their denominators are 42a squared b squared. Okay, so I'm just going to rewrite this so I have room to write next to it. Whether or not you want to do that on your sheet, that's up to you. All right, so then to get a common denominator, I know I have to multiply by something to make my denominator 42a squared b squared. So if I have a denominator in my first fraction right now of 6b, to make 6 42, I have to multiply 6 by 7. And then if I need my variables to be a squared, b squared, and right now I just have b, I'm going to have to multiply by a squared and then b to the first power, so that the b's will multiply to be b squared. So you're figuring out what do you multiply by to get it to equal your least common denominator. I then have to multiply the top of that fraction by the same thing, 7a squared b. And then for the second fraction, I already have the variables that I need. I just need to make the 14 equal to 42. And I said that was 14 times 3, so I need to multiply that denominator by 3, meaning I have to multiply the top of that fraction by 3 as well. So then for the first fraction, if I multiply across the top, remember when you multiply variables, if their variables are the same, you add the exponents. So I will have 7 times 5, which is 35. A squared times a squared is a to the 4th. And then I have b over my denominator will be 42a squared b squared. And then plus, for the second fraction, 9 times 3 on top is 27. Over the denominator again, 14 times 3 is 42, a squared b squared. And then from here, you just want to write your answer as one fraction. So when you have fractions then that have the same denominator, what you do is you add their numerators together and you keep the denominator the same. So the denominator is going to be 42a squared b squared. But here you have to ask yourself when you add the numerators, are these like terms? I hear some no's. They are not like terms. They do not both have the same variables with the same exponents, meaning you cannot add the 35 and the 27 together. So your numerator will stay these two terms separated. So the numerator will just be 35 a to the 4th b plus 27. You're just writing it as one fraction, not as two separate fractions. And this would be your final result. Okay, so make sure you're not actually adding or subtracting terms together unless they're like terms. Questions on that one? All right, so what I actually want to do here, example 3 is similar to the one we just did. I want to skip ahead to example 4 since those denominators are different, set up differently. So for example 4, so this would be like the last two examples we did on the front for finding a common denominator. I first need to factor both of these denominators. Okay, so for the first denominator, I have a trinomial, so I need to figure out what multiplies to negative 6 and adds to negative 1. So what would multiply to negative 6 and add to negative 1? Negative 3 and positive 2 if you want to add to a negative 1. Okay, so I'm going to rewrite this. I still have x minus 1 on top, and I'm going to write the denominator in factored form as x minus 3 times x minus 2. And then I have minus. My second fraction is still going to have a numerator of 4. How would I factor 5x plus 10? GCF of 5. So that would be 5 times x plus 2. Oh, and I wrote this wrong. This should be x plus 2, not x minus 2. And that first one, So first denominator should be x minus 3x plus 2. Second denominator is 5 times x plus 2. So now for these I think might be a little easier to figure out what the least common denominator is or what to multiply by. So I'm going to go straight to the multiplying part. Look at your two denominators. Looking at my first fraction and comparing it to the second one, I need these denominators to match. So the first denominator already has an x plus 2 like the first or like the second one does. The second one though has a factor of 5 that the first one doesn't, meaning I would have to multiply that first fraction by 5. So that first fraction needs a factor of 5, and I would have to multiply by 5 on the top as well. Then for the second fraction, again, they share an x plus 2, but the first fraction has an x minus 3 that the second one doesn't have. So I'd have to multiply the second fraction by x minus 3, and I have to multiply by x minus 3 on the top as well. So then both denominators will have a 5, an x plus 2, and an x minus 3. And they'll be the same. Okay, so then I'm going to include parentheses around this x minus 1 that's on the top of that first fraction. So I will have, and what I'm actually going to do here is distribute this 5 right away. So along the top, because on the top you are going to want to simplify, so distribute if you can. I'm going to distribute the 5 to the x minus 1. So I will have 5x minus 5 over, and leave your denominator in factored form, so 5 times x minus 3 times x plus 2. And then I have minus, and on the top of the second fractions I can distribute that 4 to the x minus 3, so I would have 4x minus 12 over 5 times x minus 3 times x plus 2. And then because my denominators are the same, I can write this as one fraction. My denominator will stay 5 times x minus 3 times x plus 2. And when I subtract along the top, I can only subtract terms if they're like terms. Now careful with subtraction as well. So along the top, I'm going to have 5x minus 4x, because they're like terms, so I would just have 1x or just x. And then I have negative 5 minus negative 12. So that's really negative 5 plus 12. So I then would have a positive 7. So I have an x plus 7 on the top. If you wanted to, you could rewrite this minus, distribute the negative, so have it be adding a negative 4x plus 12 if you wanted to distribute that negative through. And then if it helps you as well, you could put the x plus 7 that's on top in parentheses just to know nothing is going to cancel out. This would be the final result. Okay, questions on that one? They're just a little different. Okay, so I would like you to simplify example 5. I'll come around, I'll check, I'll answer questions, I'll pass out the practice assignment for this as well, but simplify number 5.